Hello guys, can you see this book?
Yes, sir.
Yes, sir.
Hello. Any doubt from last class? So today we are going to discuss Compton scattering. What is Compton scattering? We have some sample, some X-ray fall on it, and we have something in output. Okay. So it's a kind of interaction of some light ray or some electromagnetic signal with the sample. Or it's a light matter interaction. Have you seen such interaction before? क्या इससे पहले भी आपने कहीं देखा है लाइट को मैटर के साथ इंटरेक्ट करते हुए?
Photoelectric effect.
Right. And what we have in this effect? We have a sample, some electromagnetic signals come, and this signal is absorbed by the sample, and we get electrons in the output. And this phenomena is working at low intensities. Compton effect is also same. We have electromagnetic wave which is now X-ray. It falls on some sample, but in the outcome we not only get the electrons, we also get X-rays. So let us say these X-ray has some wavelength lambda. These X-ray have wavelength lambda prime. Okay. What is the difference between photoelectric and Compton effect? This is low intensity or low energy.
Only electron comes.
This is at high energy. You know the energy of X-rays is much higher than the regular light. So this is explained using particle nature of light. Particle nature means photon nature. It also uses the same phenomena, particle nature or photon nature. So if explanation is same, why do we get different outcome? यदि incoming part same है, only difference is in the energy. The theory which explains this phenomena is also same. What is the reason that we get different outcome? So what is the theory of photoelectric effect? According to photoelectric effect, according to Einstein, this photon it's behave like a particle. I mean, either we have this complete particle or we do not have any particle. So either this photon will have energy h nu or there is no photon at all. Okay. So this photon is completely absorbed by this electron. Now there is no photon. So before incidence, we have a photon and electron at rest. After incidence, we have only electron, photon is absorbed, and this electron at some energy. Okay. Now, if this energy is enough to bring this electron out of atomic bonds, you get a free electron. Otherwise, there is no current. Same phenomena is happening here also. वही phenomena यहाँ पर भी हो रहा है. Only difference is now this photon is extremely high energy. Okay. So before incidence, we have this photon, and we have these electrons which are moving around atom, or for now let me call it that they are at rest. Okay. After incidence, what will happen? Now this process is divided in two parts. This photon is absorbed by this electron. So electron at high energy. Okay. And now this high energy electron emits photons of different wavelength. So it is still true that the energy of photon is not decreasing. The incident photon is completely absorbed here, and once it is absorbed, this electron emits another photon, and its wavelength, its direction can be quite different from the incident photon. So we have a scenario like this. This photon is coming. Guys, just 1 minute. Okay, so and it falls on an electron, and after incidence, the electron, let us say, goes in this direction, and this X-ray beam is going in this direction. Okay, this has some incident. This is the final wavelength. Okay. Guys, just 1 minute. I think there is some problem here. Sorry. This is before incidence. And this is after incidence. So what Compton observed that when we allow some high energy X-ray on some target, we get another X-ray of higher wavelength. Higher wavelength means lambda prime is greater than lambda. It means the outgoing X-ray has lower energy, and this lambda prime depends on angle of scattering. Means it is function of this angle. So how much this lambda prime is scattered by this angle theta. Okay. So what is the explanation behind this? I mean, why do we get a different X-ray, and why do we get why this lambda prime depends on this scattering angle? So this particle nature can explain it quite easily. So this is a elastic collision. Elastic collision means momentum is conserved here, energy is conserved here. And it is inelastic scattering. Do you know when we say scattering is elastic or inelastic? कब scattering elastic होता है, कब inelastic हो जाता है?
No, sir.
So depending upon energy that the electron get.
Incident wave or particle. If kinetic energy of incident part is changing, then it's inelastic scattering. If kinetic energy does not change, I mean, let us say we have a scattering like this. This is a heavy particle. This is some small particle. Let us say both are positive charges. It is coming towards this, and obviously it will not collide, but there is a high force of repulsion. It goes like this. What is the incoming energy? Let us say half mv naught square. What is the outgoing energy? Same. Then it is a elastic scattering. The kinetic energy does not change in this process. It was changing in this intermediate region, but incoming and final energies are still same. Okay. So this is elastic scattering. When kinetic energy change of incident particles, then it is inelastic. So you can say here we incident X-ray of some energy Sc by lambda, whereas we are getting X-rays of different energies. That is why it is inelastic. So let us apply both the law and let us see what results do we get in this case. So let us apply momentum conservation first. What is the incoming momentum? If we have a wave of wavelength lambda, what is the equivalent momentum of photons?
H by
H
lambda.
upon M.
You know lambda is equal to h upon mb from de Broglie relation. Mb is p or p is equal to h upon lambda. Okay. So this is the incoming momentum along x-axis. What is the outgoing momentum after collision? We have h upon lambda prime cos theta along x-axis from the X-ray. We also have, let us say P is the total momentum. This will also be some angle. ये भी कोई ना कोई angle ही होगा. Let me call it phi. So if P is the total momentum, P cos phi along x-axis. This is the outgoing along x-axis. What about y? So initially there is no momentum along y. Finally also there will be no momentum along y. So 0 is equal to how much momentum do we have along y-axis here? From the x-ray part we are getting h upon lambda prime sine theta along plus y-axis minus p sine phi. Okay, so we have these relations, or I can say, let me just write it, h upon lambda prime sine theta is equal to p sine phi. What is p? P is the momentum of electron. Okay. Now let us apply energy conservation. So initial energy is Sc upon lambda. Final energy is Sc upon lambda prime plus the energy of electron. EE, let me call it PE, PE. So subscript with small e means for electron. Okay. So we have these three relations. We have one more relation. One thing is here. Before incidence of X-ray, this is the energy of X-rays. What is the energy of electron? Electron का energy कितना है? This is not moving, but it still have rest mass energy, right? After incidence, this is the energy of X-ray. This is the energy of electron. How much EE? This is equal to mc square. M is the dynamic mass. Okay. What is the connection between energy and momentum of electron? This you know from relativity. Why do we apply relativistic formula? Relativistic formula क्यों लगाया हमने? Because
Speed.
this energy is so high that the electrons, which are, although they are not completely free, but with respect to this energy scale, they are like free electrons. I mean, it's very easy for these X-ray to kick out these electrons from the atoms. And these electrons move at relativistic speed. Okay. That is why we are applying a relativistic limit here. So let us put all this formula together. And what is our goal? हमारा goal क्या है? To find connection between lambda and lambda prime. So h upon lambda cos theta is equal to h upon lambda prime. Sorry. And h upon lambda prime sin theta is equal to Pe sin phi h upon lambda hc upon lambda plus m naught c square is equal to hc upon lambda plus ee and e square c square is equal to m square c4 is equal to p square c square plus m naught square c4. Okay. So let us find lambda and lambda prime. So what we are going to do? Let us kill 5 terms first. So what I'm going to do is, let us take these two equations. So PE cos phi is equal to h upon lambda minus h upon lambda prime cos theta. PE sin phi is h upon lambda prime sin theta. If I take a square and then sum it up, I am getting this. So what I get? H square upon lambda square plus h square upon lambda prime square cos square theta plus sin square theta becomes 1. And the third term is minus 2 h square cos theta upon lambda prime. This is PE square. Okay. Now let us calculate energy from here. How much is energy from here? Energy is equal to hc upon lambda. This is hc upon lambda prime, right? Minus hc upon lambda prime plus m naught c square. So we have momentum, we have energy, and we know the relation between momentum and energy. So let us apply this relation here. And energy square means this term square. So sc upon lambda prime plus m naught c square is equal to momentum square. Momentum square means this strange term into c square. H square c square upon lambda square. H square c square upon lambda prime square 2 h square c square cos theta upon lambda prime plus this additional term here. Okay. So I think now we are left with lambda and lambda prime only and some other constant. Now we just need to simplify this. Okay, so let's expand this. The square of first term means h square c square upon lambda square square of second term now plus 2 times product of these two. So 2 hc upon lambda m naught c square minus 2 hc upon lambda prime m naught c square. This thing is equal to this thing. M naught square C4. I think many things are going to cancel. This term cancels with this. This term cancels with this. Okay. Anything else can we cancel? I think no. All right. So let us rewrite this thing now. 2h square c square upon lambda prime. This is common. What we have inside 1 minus cos theta is equal to 2hc m naught c square. This is common from here. And 1 upon lambda minus 1 upon lambda prime. I can say lambda prime minus lambda upon lambda prime. I think again we can cancel many things. 2 cancels. Square cancels with these quantities. This is this c also cancel with this square. Okay. And lambda prime cancels with this. So what we are left with now? क्या बचा हमारे पास? Lambda prime minus lambda is equal to h upon m naught c 1 minus cos theta. What is the unit of this quantity? इस quantity का unit क्या होगा?
Meter.
It is the same as
Meter.
wavelength, or this is called Compton wavelength. Now you can see, depending on the angle, we have different X-rays. So at theta is equal to 0, we have the same X-ray which we allow to incident on the sample. It means there is no scattering at all. For all other angles, energy decreases and accordingly wavelength increase. So this is the Compton effect or Compton scattering. If you try wave theory cannot answer it, but particle theory can answer this. Okay. Any doubt here? If there is no doubt,
Sir?
and yes,
So why is it that the photon is losing energy? I mean, can't it be the other way around, that the photon gains energy upon interaction with matter?
see, photon is. Sorry, ask your question again.
Sir, the photon in question here, why is it losing energy?
Why is it losing energy? See, the incident photon and the emitting photon are not same. I mean, these two photons are not same photons. This is photon A, but this is not photon A. This is a new photon. Okay, so it is not like photon is losing energy. Photon A is completely absorbed here by electron. Now photon A does not exist at all. It is dead. This is a new photon generated by this highly excited electron. Okay. How does this generate photon? Because it gets energy from this previous photon, and because of this energy, it is accelerating, and when it accelerates, it emits some radiation. Okay, so these two photons are completely different from each other, and therefore nobody knows what could be this angle. I mean, you cannot predict theta from the information given in photon. आप थीटा को फोटोन ए से नहीं पता कर सकते कभी भी. Is that your doubt? So the situation is like this. This is a photon A, incoming photon. It falls on this electron. Now this electron absorbs this full photon, and after absorbing this photon, this electron is at high energy. So when it gets energy, its speed will increase and it moves at relativistic speed. So because its speed is increasing, I mean it is accelerating in a short period of time, and in this acceleration, it emits a radiation. This is photon B. Okay. Is it clear?
Yes, sir. Thank you.
Now, what is the wavelength of photon B? What is the nature of photon B? That nature can be completely independent of A. B का जो भी nature होगा, वो A से completely independent होगा. There is no connection between A and B. But yes, this whole process has to respect fundamental laws. Fundamental laws means momentum is always conserved as long as we are not applying any external force. There is no loss of energy. Energy loss कहीं नहीं हुआ है. If these photons are not having equal energy, it means remaining energy is with this electron. जो एनर्जी फोटोन तक नहीं पहुंच पाई है वो एनर्जी इलेक्ट्रॉन के पास है. Okay? So there is no loss of anything here. Only thing, all the things are now redistributing. Momentum is redistributed. Initially it was completely with photon A. Now it is shared in electron and new photon. Same with the energy. Initially it was completely with A. Now it is shared between electron and new photon. Right? Any other doubt? What happens if you allow even higher energy rays? यदि आप एक्सरे से भी ज्यादा एनर्जी की रेज किसी सैंपल पे गिराते हैं,
Sir, more than one electron can.
one photon can interact with only one electron. Okay.
Okay, so sir, the emitting rays will be of more
So
wavelength.
if you are emitting, let us say 100 rays, they will kick out at the most 100 electrons, and you will get 100 rays in the outgoing directions also. But they will have different wavelength. Okay. You can never ever share one photon with two or more electrons. You cannot share one photon or one particle with more particles. एक photon, एक particle का existence एक ही बार है. It will interact only one of the electron. वो किसी एक ही से interact कर सकता है, and accordingly you will see the consequences. But usually in an X-ray beam, we have many numbers of photons. एक ही X-ray beam में millions of photons होते हैं. Each one interact with each electron, and therefore we get millions of electrons scattered out, and we have millions of X-ray photons in the outgoing direction. In fact, in photoelectric effect also, photoelectric effect में भी one photon interact with only one electron. एक photon एक ही electron से interact कर सकता है. आप photon को share नहीं कर सकते कभी भी. You cannot divide one photon in two part and you will say that ये किसी एक को चला गया दूसरे को चला गया. No. Photon is one unique identity. That is why it has a particle-like behavior. Can you divide one particle into two? क्या particle को दो में divide कर सकते हैं? In fact, that is the definition of particle. It is the smallest unit which cannot be divided further. Any other doubt here? So I think if no more doubt, this is the end of syllabus, and all the best for your exams whenever they come. So if there is no more doubt, I am going to end this class. If you still have doubt, please discuss among yourself, and we can have a class anytime whenever you want to discuss your doubts. Okay. So I am going to end this class here now.
So will you be taking tomorrow's class?
No,